Hey, you!
Did you know AU is gold, which is found on the periodic table, which consists mainly of metals, nonmetals, and metalloids?
Properties of metals are shiny, good conductors of electricity and heat. They are also ductile and malleable.
All these metals lose electrons very easily.
Chemical properties of metalloids. Elements gain and lose electrons when bonding.
Physical properties of metalloids can be shiny or dull. Conductivity of heat and electricity is better than nonmetals.
Metalloids.
Nonmetals have properties opposite those of metals. Nonmetals are brittle, non-malleable, or ductile. Poor conductors of heat and electricity, they tend to gain electrons in chemical reactions. Some metals are liquid.
Generally, block elements may contain inline elements and other block level elements.
The S block holds 2 elements. The P block holds 6 elements. The D block holds 10 elements. And the F block holds 14 elements. But don't drop the F block.
The atomic size of an atom, also called the atomic radius, refers to the distance between an atom's nucleus and its valence electrons. Remember, the closer an electron is to the nucleus, the lower its energy and the more tightly it is held. The atomic radius increases moving down a group. Once again, protons are added moving down a group, but so are new energy shells of electrons. The new energy shells provide shielding, allowing the valence electrons to experience only a minimal amount of the proton's positive charge.
Alright. Moving from the left to the right across a period, the atom radius decreases. The nucleus of the atom gains protons moving from the left to the right, increasing the positive charge of the nucleus and increasing the attractive force of the nucleus upon the electrons. Electrons are also added as the elements move from the left to the right across a period. But these electrons reside in the same energy shell and do not offer increased shielding.
Ionization energy and electron affinity.
The process of gaining or losing electrons requires energy. There are 2 common ways to measure this energy change: ionization energy and electron affinity.
Ionization energy increases.
Ionization energy increases, but this one's broken. Electronegativity refers to the ability of an atom to attract the electrons of another atom to it when those 2 atoms are associated through a bond. It is based on an atom's ionization energy and electron affinity. For that reason, electronegativity follows similar trends as its 2 constituent measures.
Electronegativity generally increases moving across a period and decreases moving down a group. Fluorine is the most powerful electronegative of the elements. Electronegativity plays a very large role in the process of chemical bonding. Lowest electronegativity.
Highest electronegativity. Electron affinities down a group. Electron affinities change little moving down a group, though they do generally become slightly more positive. The biggest exception to this rule are the third period elements, which often have more negative electron affinities than the corresponding elements in the second period. For this reason, chlorine has the most negative electron affinity.
Electron affinities going across the period. Electron affinities become increasingly negative from left to right. Just as in ionization energy, this trend conforms to and helps explain the octet rule. The octet rule states that atoms with close to full valence shells will tend to gain electrons. Did you know A use gold? Gold is found on the periodic table. Now I'm going to know this by heart.
Properties of metals are shiny, good conductor of electricity and heat.
It supports my abs.
Mine are free flowing.
You guys, it's on right now. We're recording.
Here you go.
We're recording.
Oh, alright. I'm good, just keep going. Come on!
Go.
Ionization energy and electron
I was
affinity.
ready.
Okay.
I'm going to do that.
Alright, I'll cut this. Okay,
Just leave it right where it is.